Hey, geometry. This is 4.2, reflections. Okay, reflections of the way things used to be. So, just kind of like doing in a mirror. As I look at you, look at the screen, I see my reflection right here.
I shut the lights on.
Okay, thank you.
They're all out.
Okay, thanks. So, this is going to work a lot with the coordinate plane, and we're going to have some formulas for reflecting things in the coordinate plane, and those are things we'll have to try to work on and review and memorize. You will want some graph paper. Some of the stuff we'll do later on will be useful to have some graph paper. We can just make things a little bit bigger and not try to squeeze them into the workbook, student journal here. So we're on page 99, almost cracked into the top 100. Okay, and so a little bit on the vocabulary. Reflection, this is going to be a transformation. It's another type of transformation, just like a translation. That uses a line like a mirror. Okay, we're going to stop right there. Just uses a line like a mirror. So whatever happens on one side of the line, so this is a point, and this is our line. If you reflect it over, it's going to land here. We're going to call this A. That's going to make this one A prime. So reflections over the line, we're going to notice that this distance here is the same as this distance here. This is going to create what we call a perpendicular bisector. I've had some questions with that. Okay. The line of reflection, this is just the mirror line. So they just call that the mirror line. A glide reflection, okay? This is going to be a translation followed by a reflection. That's called a glide reflection. So that's when you slide something and then you're going to reflect it over. Okay. So if I want to reflect over my finger here, there we go. Let's go this way. And so I'm going to slide it, then I'm going to reflect it over. That's a glide translation. Line symmetry. This is when a figure can be mapped onto itself. A figure can be mapped onto itself by a reflection in a line. Okay, a figure can be mapped onto itself by a reflection in a line. Those types of questions there, I'm just going to jump ahead, those types of questions are just like what you have in question 101, page 101, questions 9 through 12. Identify the line symmetry, if any, of the word. So if you have the word moon, can you draw any line that when you reflect it over that line, so imagine folding the piece of paper over that line of reflection, okay, can you find a line that does that? So if I draw one here, the O's work, but the M and N doesn't. If I draw it up and down, the M doesn't match up with the N. Okay, so this one has none. That has no lines of symmetry. The word wow, though, you can draw it right down the middle. If I draw a line of symmetry right down through there and fold it over, take your imagination, imagine folding that over, the W would match up with the W, that half the O with that half the O. The word kid, okay, where can we do it? You go right through the middle like that, horizontal line. Reflect it over that. And it looks like the same with the word dock, horizontal reflection line right through there. So identify the line symmetry. There's one line of symmetry for each of those. The line of symmetry, that is just another, that's similar to the line of reflection. So these are kind of the same terminology for all the same thing. Line of symmetry, line of reflection, mirror line, all kind of the same stuff. Okay, this is that, down here at the bottom of page 99, there's that word perpendicular bisector, that if you take a point and reflect it over the line is then the perpendicular bisector of the segment that joins those 2 points. Okay, so a line of symmetry is a perpendicular A line of symmetry is a perpendicular bisector of the segment connecting the pre-image with the image. A line of symmetry is a perpendicular bisector of the segment connecting the pre-image with the image. Okay, so here's our rules. There's our rules for reflections. If we're reflecting over the x-axis, then its image point is A, negative B. So if you have a point AB, and you reflect it over the x-axis, then its image is A, the opposite of B. So think of it this way. Let's make my line. So if I have a point 2, 3, if I reflect it over the x-axis, it's going to be down here at 2, negative 3. This is A, this would be A prime. So that's a reflection over the x-axis. So we're going to do the opposite y value. So when you reflect over the x-axis, it's the opposite y value. If AB is reflected in the y-axis, then notice it's the opposite of AB. So when you do the y-axis, it's the opposite x value. Because here I'm 2 units to the right. If I reflect over the y-axis, I now have to be 2 units to the left. I'll call this A double prime. That'd be negative 2, 3. Okay. So opposite x, y values. AB is reflected in the line y equals x. This is y equals 1x plus 0. That would be this line right here. Okay, so that line. Then its image point is BA. So what you're doing when you're reflecting over the line y equals x, you're switching your A and your B. So A goes to the B goes to the A. So that would make my new point over here, call this A triple prime, and that would be 3, 2. Switch your x and y. So 2 goes to the 3 goes to the 2. And now the reflection in the line y equals negative x, that's y equals negative 1x plus 0. Negative 1x plus 0, that goes this direction. So I'm reflecting over that. You want to switch x and y, and you want to take the opposites of both. Okay. So if I have the point 2, 3, we're switching x and y, switch x and y, take the opposites of both. So that's going to go to switch them. So the 3 now is in front, that would be negative 3, and the 2 is in the back, that will be negative 2. So negative 3, negative 2. I'll call that A to the 4 prime, A to the 4th. Okay. So negative 3, negative 2, that would be reflected over the green line there. Postulate says a reflection is a rigid motion. That just means the same, keeps the same size and shape. Keeps the same size and shape. Okay, so we're going to do these on here. Some of the ones on the next page, we'll get some other graph paper. So graph A, triangle ABC, and its image after a reflection in the given line. So A is negative 1, 5. Oh, we are getting off the chart. Okay, I'm getting a new one. Get some graph paper. So A is negative 1, 5. 1, 2, 3, 4, 5. B is negative 4, 4. 2, 3, 4. And C is negative 3, 1. Okay, so there's triangle, whoa, there we go. Triangle ABC. And I'm going to write down these translations. So we want to reflect it in the y-axis. So I look and be like, okay, reflection in the y-axis, AB is going to go to negative AB. So I'm going to write A prime. I know AB maps to the negative AB. That's kind of a rule like we did with translations. AB maps to negative AB. I write that down so I remember it. That makes A prime going to be at positive 1, 5. B prime is going to be at 4, 4, positive 4, 4. C prime is going to be at 3, 1. Okay, get in practice of writing those ordered pairs down. When we get to harder things, it will come in handy. So A prime should be at 1, 5. B prime should be at 1, 2, 3, 4, 1, 2, 3, 4. C prime should be at 3, 1, 1, 2, 3, 1. Put the primes on there. So once you draw it, make sure that it looks like it's the same size and same shape. That's what it means by when it's a rigid transformation. Eventually we'll get to non-rigid transformation. So that looks okay. Looks good. Let's move on. Okay, number 2. A is 0, 2. B is 4, 5. 2, 3, 4. 1, 2, 3, 4, 5. And C is 5, 2. Okay, we're reflecting in the x-axis. So I check my rule. X-axis says AB goes to A, the opposite of B. So AB maps to A, opposite of B. So that makes A prime is going to be 0, negative 2. B prime is going to be 4, negative 5. C prime is going to be 5, negative 2. Okay, let's put those points on there. Keep moving this around. It's A prime, C prime, and B prime. Okay, you kind of get an eye for this. You can flip them over rather quickly. Get that job done. Okay. Here's a few new ones here. Notice, here's our triangle. Notice it's just a normal line, not a normal line. It's not a specific rule here. Y equals 1. Reflecting it over the line, y equals 1. So I'm still going to put these points on here. A is 2, negative 1. B is negative 4. 1, 2, 3, 4, negative 2. There's A. There's B. C is negative 1, negative 3. There's my triangle. And reflecting it over the line y equals 1. So this means we don't have a specific rule. We're just going to use the graph. So y equals 1 has a y-intercept of 1 and is a horizontal line. So y equals 1 right along here, all the way along here. This is our line of reflection, line of symmetry, whatever you want to think about it. So y equals 1. We're going to reflect it over, which means the distance from these points to this line has to match up on both sides. So if A is 2 units away here, A prime is going to be 2 units up here. If C is 1, 2, 3, 4 units away from my line of symmetry, line of reflection, and C prime is 1, 2, 3, 4. This has to be a bisector. B prime is 1, 2, 3, so 1, 2, 3. And you could write your ordered pairs then down if you needed to do that at this time. Okay, so again, look, does it look like the same size, same shape? It does, so we are ready to roll. Okay, 4. All those points on there. Again, we have, this is going to be a vertical line at x equals negative 3. This has no specific rule. This was a horizontal line at y equals 1. Horizontal line at y equals 1. So I'm going to put all my points on here. A is negative 2, negative 2, 3. B is negative 2, negative 2. C is 0, negative 2. Notice I sometimes wait to put my letters on my points because I'm not sure sometimes what side of the point to draw them on. I want my letters on the outside of my shape, so I kind of know where my shape is, and I'll put my labels on there. We're doing it over the line x equals negative 3. So x equals negative 3 would be x to negative 3. That is a vertical line. So we're going to reflect it over. Distances should match. So A is 1 unit, so that should be A prime. That should be B prime. And C is 1, 2, 3, so 1, 2, 3, C prime. Hopefully these are fairly straightforward for you, and you're telling me at this time to get a move on it, Mr. Leitner. We got this. Okay, so that takes care of that page. These questions here, graph the polygon's image after reflection in the given line. So y equals x. So y equals x is, there we go, the line that goes through here with a slope of 1, y-intercept is 0. And what's helpful sometimes is to write down the rule. So A, B goes to B, A. That's the rule for line at y equals x. You can always look back on your chart and see what it is. So A is negative 3, 2. That's going to map A prime to 2, negative 3. So 2, 1, 2, 3. 2, negative 3. There's A prime. B is at negative 1, 2. B prime then is going to be at 2, negative 1. Trying to get the picture where this is going to be. I want you to notice that AB is a horizontal line segment. A prime, B prime is going to be a vertical segment. That's what happens when we reflect over a diagonal line. C is at negative 1, 1, 2, 3, 4. Negative 1, 4. C prime is going to be at 4, negative 1. There's C prime. Two of these. And D prime has to be down there. Keep the same size, same shape. That'd be at 4, negative 3. 4, negative 3. So there's D prime. Okay, looks like a reflection. I could fold my paper over at that point on that line, and they should match up. One side to the other side. Everything should be the same distance apart. Okay, reflecting this, y equals negative x, that rule, look up the rule, AB is going to the opposite of B, opposite of A. Everything's backwards. Everything's backwards. So, y equals negative x, we're reflecting over this line here, slope of negative 1. Through the y-intercept. Okay, so A, we're counting by 2. So A is at 2, 0. A prime, then, switch them and take the opposite of it all. Switch them and take it opposite. So it's going to be 0, negative 0. Don't put negative 0. And then negative 2. A prime is going to be 0, negative 2 right there. Looks like the same distance away from the line as A. B looks to be at 5, 3. So B prime is going to be, switch them and take the opposites, negative 3, negative 5. Negative 3, negative 5, B prime. C is at 2, 2, 4, 5, 2, 5, C prime. Switch them, 5 goes first, opposite, negative 5, negative 2. Negative 5, there's negative 4, negative 5, negative 2 right there. And then D. D looks to be at 1, 4. D prime, switch them, take the opposites, negative 4, negative 1. Ooh, squeezed up in there. And get our shape. Okay, we're getting there. Good work. These are the glide reflections. So notice we have a translation followed by a reflection. Okay, so we have the vertices J is at 3, 1. These are the ones I'm going to do this again. Use some other graph paper. J is at 3, 1. 1, 2, 3, 1. K is at 4, 2. And L is at 1, 3. We have J, K, L. Looks like a right triangle. And it is one because these two slopes are negative reciprocals, 1 and negative 1, so it forms a 90-degree angle. Okay, so we want a translation first, and then we want a reflection in the line y equals negative x. So if I have J at 3, 1, J prime is going to be x minus 6, so 3 minus 6 is negative 3, y minus 1, so 1 minus 1 is 0. So J prime is at negative 3, 0. Okay. Do this for each of these. K is at 4, 2. K prime is going to be 4 minus 6, so negative 2. And 2 minus 1, which is 1, so negative 2, 1. There's K prime. And L is at 1, 3. L prime, 1 minus 6 is negative 5. 3 minus 1 is 2. So L prime is at negative 5, 2. 3, 4, 5, 1, 2. Okay, so there's the glide. We have glided. Is that okay if I say that? Glided. The paint brand called Glidden. So sure, why can't we say that? And then we have the reflection in the line y equals x. So here's my line y equals x. And we're going to reflect that over. Sometimes the easy way also is just to look at the distances that you're doing. So there should be K prime. J should be right there. Sorry, this should be double prime. So K double prime is there. J double prime is right there. Kind of squeezing in there. L double prime would be right there. All these should be the same size, same shape. You can also follow the rule here. Remember, this switched everything around. So you could say J double prime should be 0, 3. K double prime should be negative 1, 2. Switch the order and take the opposites. L double prime should be negative 2, positive 5. Negative 2, 5. Okay. Another glide translation. Notice this is a reflection in the line x equals 1. That is vertical. So 3, 1, 4, 2, and 1, 3. J, K, L. See if we can speed this up a little bit. We're going to shift it. X stays the same. This just means we want to go down 4. So 1, 2, 3, 4. There's L prime. 1, 2, 3, 4. J prime. 1, 2, 3, 4. K prime. So there's our first image. Reflection in the line x equals 1. So here's the line x equals 1, x in axis of 1. We're going to reflect it over that. Okay? So that's going to keep L the same as L double prime. The point is on the line, so it stays there. J is going to be 2 units on this other side. J double prime. K is going to be 3 units on this other side. K double prime. And there you have your reflection. Okay. Final thing is, you're placing a power strip along a wall that connects 2 computers. Where should you place the power strip to minimize the length of the connecting cables? So you want the shortest length possible for your connecting cables. you want to reflect this over. So I'm going to measure this distance, whatever it is. Doop. I'm going to reflect it over the same amount. Doop. So maybe about right there. So reflect it over. That's the first thing you do. And then the second thing we're going to do is we're going to draw a segment connecting this point with that computer. So draw this segment. Okay? And what that means is this point of intersection right there, you want to use this point for the shortest distance. Use that point right there for the shortest distance. So you reflect one over, draw the connecting line to the other one, and then that point right there, because if I connect this segment should be the same as that segment. Okay, they should be congruent. So this is going to be the shortest distance between computer A and computer B with that port right there. The questions that may arise with that, oh, here's a good picture for a glide translation. Okay, slide and then reflect over. Okay, it could be this. Find point C on the x-axis so that AC plus BC is a minimum. Find point C on the x-axis. So if I have points at 1, 4, 2, 3, 4. That's the point A at 1, 4, and point B at 6, 1. 1, 2, 3, 4, 5, 6, 1. They want us to find point C along here that makes A to C plus B to C the shortest distance. We're going to have to reflect A over. So reflect over the x-axis. That's 4 up, so it's going to be 4 down. So there's A double prime. Connect these 2 points right here. And then this is the answer, which would be 5, 0. Okay, so if you put that point there, the distance from A to C plus B to C is going to be the minimum distance you have. If you slide it to the left, it's going to get longer. Okay, good work. That took a little bit longer than I anticipated. I apologize for that, so I'll just wrap it up, and we'll see you in class.